today's video, I'm going to talk to you about the concept of a linear function. This is for basic algebra math, where if you're into algebra or pre-calculus, learning about the linear function is very important because it helps you understand how a rate of change between the input and output is in a straight line or a straight pattern. So a linear functions would have a mathematical formula like this: y equal mx plus b, okay? Where if you see the y, it stands for the output, okay? So I'm going to put the y as the output. The m is the slope or the rate of change, okay? So slope or rate of change. For the x, which is the input, and the b is the y-intercept or the output when your x is 0, okay? So people would often say it's a y-intercept, or in common terms, it is the output, input, x equal to 0. Okay, so based on these equations, you can come up with plenty of numbers that goes along with it. Okay, so one example of a linear equation can look like this, which is y equal to x plus 3. Okay, and if you want to visualize these equations in terms of table or graph, you can also do that. So that's the nice thing about algebra or function, is that you can actually visualize what an equation looks like. So if I draw this a table from a linear equation, I would have x and then I would have y. Okay, so what I can do is I can choose a select between any input that I think can select. Okay, so let's say if I put input equal to 0. So if it's 0, then 2 times 0 is 0 plus 3 is 3. So I have my y would equal to 3. Okay. If I choose my input is 1, then 2 times 1 is 2 plus 3 is 5. And if I choose my input is 2, 2 times 2 is 4 plus 3 is 7. Okay. So as you can see that there is a change in the output based on the unit change in input. Okay. So the rate of change is how much? 2 for each one. That's why you see there's a slope associated with the rate of change. Okay. Now, if I am going to draw this out based on the table, right, I can have my x on the x-axis and y on the y-axis. And with this table that I have already drawn out from the equation, then I can start with 0, okay? Then it goes to 3, okay? And then 1, then I go to 1, 2, 3, 4, 5. Okay, so I can go 5 here. 0, 1 is 5, and 2 is 6, 7. 2 is 6 and 7. And I'm going to have right here. So if I connect all of these dots together, I will have a straight line. Okay, so pretty much straight line. And I can continue going both directions. Okay, so any point that you having down below or in reverse, you're going to have a 2 in additions or rate of change added to the equation. So this is going to be 7 plus 2 is 9. Okay, 9 plus 2 is 11. Okay, so you can pretty much anticipate what the linear equation is going to help you identify the input and the output in a straight line rate of change. Okay, now let's go into the example. Suppose the world current oil reserves are 1820 billion barrels. Okay, if on average the total reserve is decreasing by 25 million barrels of oil of each year, then you're gonna get the linear equation for the remaining oil, R in terms of T, and the number of years since now. Or 7 years from now, what will the oil reserves be? And the third question is, if the rate of depletion isn't changed, when will the oil reserve be depleted? Okay, so in order to do this problem, step number 1 is you are going to set up the key data. Okay, so step number 1 is first, you're going to have the current oil reserve, right? So R, I call it current, is equal to 20 billion. Okay, now, if on average the total reserve is decreasing by 25 billion, so you're going to say the depletion rate, okay? Depletion rate is equal to 25 billion, okay? And then you also need to identify the t or the r in the number of years. So going to say t or equal to time is the number of years, or r is the reserve. Okay, so based on these, if you remember the functions y equal mx plus b, we can pretty much identify the r current is when the time is equal to 0, is the current date, right? So that's equivalent to b. The depletion rate is 25,000 per year because this is the rate of change. That's going to equal to m, okay? And the number of years is equal to x, and then the reserve is the y that we are looking for, okay? So that's step number 1. Now, how do you get, so now if you put those together, step number 2, okay, the equations that you're going to bring in, all of these, is r equal to m is 25, and then x is the t, right? 25t, and then you're gonna, hold on, it start with the 25 is the depletion. And remember, we are having our rate depleting, so it's not an increasing. So this is negative 25, okay? So we're gonna have a negative 25, and then x, and then we plus to the current rate of 1820. Okay, so that's step number 2. We want to be able to pay attention to the equations that we are giving. So right now, if I rewrite this equation, it's going to be equal to 1820 minus 25x. Okay, that's the equation that we are looking to solve. Now, so now we're done with A. Okay, A checked. Now for B, okay, I'm gonna do a short part for B over here. Okay, for B is they're asking 7 years from now, what will the oil reserve be? Okay, so as we know that R equals 25x, so this is the x or t, we can then find R of 7 years from now, which is the input. So you have negative 25 times 7 plus 1820. Okay, that's going to give you an answer equal to 1645. Okay, so that's your answer for this equation. Now, part C is when would oil reserve be depleted? That means like they're completely gone, right? So this is for B. And for C, in order to know when it's completed, then you're going to set R equal to 0. Okay, and you're going to find the X or the time that is depleted, 1820. Okay, and if you solve for T, that T is going to be equal to 72.8 years in these equations. So that's how you solve for simple linear equation in applications, okay? So you have step 1 is to be able to list out all the information. Step 2 is to write the equation. And then step 3 is to plug in the numbers, finding the reserve at the certain years, or finding at what year is the reserve will be completely depleted. Okay, hope you like this video. If you'd like to learn more of these things, feel free to click subscribe and I'll give you more soon.